Imagine, friends, a universe so vast, so breathtakingly immense, that it makes your heart race and your mind reel. The stars, the galaxies, the infinite possibilities, they call to us, whispering dreams of exploration and discovery. But here's the gut-wrenching truth. This same vastness is our greatest barrier. The cosmos, with all its wonders, feels like a cruel tease. Even if we pinpoint a perfect Earth-like planet in a distant galaxy, a paradise where humanity could thrive, it's so far away that reaching it seems like a fantasy. The distances are so colossal, so soul-crushingly immense, that they mock our ambitions. Can we ever break free from our cosmic cage, the Milky Way, and soar to the stars beyond? Or are we doomed to gaze longingly at the heavens, trapped forever in our galactic home? Buckle up, because today we're diving into the mind-blowing, heart-pounding possibility of wormholes, the ultimate cosmic shortcut that could rewrite humanity's destiny. Let's start with a reality check that'll hit you like a supernova. Our Earth, this beautiful blue marble, sits cozy in the Milky Way galaxy, a swirling spiral of stars, gas, and dust stretching 100,000 light-years across. The closest galaxy to us? That's Andromeda, a staggering 2.5 million light-years away. To put that in perspective, 1 light-year is about 5.88 trillion miles. Multiply that by 2.5 million, and you're dealing with distances that make your head spin. Now let's say we hop into a spacecraft, traveling at the speed of our fastest probes, say 28,000 kilometers per hour, like NASA's Voyager 1. How long would it take to reach Andromeda? Brace yourself, 94.5 billion years. That's more than 6 times the age of the universe itself. Even if we could somehow crank our tech up to the speed of light, 186,282 miles per second, it would still take 2.5 million years to get there. And here's the kicker. Light speed is the cosmic speed limit, according to Einstein. Nothing can go faster. So what's the point of dreaming about distant galaxies if we're stuck in this slow-motion nightmare? This is where the despair sets in. The universe is a treasure chest of wonders. Exoplanets with oceans, stars with habitable zones, maybe even alien civilizations, but it's locked behind a wall of distance we can't seem to climb. Our telescopes, like the James Webb Space Telescope, launched in 2021, can peer billions of light-years into the past, spotting galaxies that formed when the universe was a baby. Yet, even with all this tech, we're like kids pressing our noses against a candy store window, unable to taste the sweets inside. The Milky Way is our home, but it's starting to feel like a prison. Is there no hope? No way to cheat the cosmic rulebook and leap across the stars? Enter wormholes, friends, the most jaw-dropping, reality-bending concept in all of science. Picture this: a tunnel, a shortcut through the fabric of space and time, connecting 2 distant points in the universe like a cosmic subway. One end might be near Earth, the other in Andromeda, or even a galaxy billions of light-years away. Step through and in minutes, hours, or days you're there. No billions of years, no light speed barriers, just pure, unadulterated cosmic magic. If wormholes exist, they could be the key to unlocking the universe, turning our wildest sci-fi dreams into reality. And the craziest part? They're not just Hollywood fiction. They're rooted in the hardcore math of Einstein's genius. Let's rewind to one of my all-time favorite movies, Interstellar. If you haven't seen it, stop what you're doing and watch it. It's a masterpiece. In the film, astronaut Cooper and his team embark on a desperate mission to find a new home for humanity. Earth is dying, and their only hope lies in distant planets. How do they get there? A wormhole, discovered near Saturn's orbit, like a glowing cosmic portal. The scene where they pass through it, stars warping, space bending, their ship diving into the unknown, is pure cinematic adrenaline. In moments, they're in another galaxy, light years from home, chasing hope. The wormhole isn't just a plot device. It's the heart of the story, a symbol of humanity's refusal to give up. And here's the mind-blowing twist. Interstellar didn't just make this up. Wormholes are real science, born from the equations that govern the universe. To understand wormholes, we need to dive into the genius of Albert Einstein. In 1915, Einstein dropped a bombshell on the world with his theory of general relativity. This wasn't just a theory. It was a revolution that redefined how we see reality. At its core, general relativity says that gravity isn't just a force, it's the bending of space-time itself. Imagine space-time as a stretchy, flexible sheet. Place a heavy object like a planet or star on it, and the sheet curves, creating a gravitational pull. The more massive the object, the deeper the curve. This idea was captured in Einstein's field equations, a set of 10 complex mathematical beasts that describe how matter and energy shape space-time. Don't worry, we won't bore you with the math, but here's the shorthand version. G mu nu plus lambda G mu nu equals, open parenthesis, 8 pi G by C to the fourth power, close parenthesis, T mu nu. Looks like gibberish, right? But this equation is the key to everything. Black holes, wormholes, the whole cosmic shebang. Einstein's equations were so profound that even he couldn't fully crack them. It took another genius, Carl Schwarzschild, to solve them in 1916. Schwarzschild showed how space-time warps around a massive object, like a star or planet. His solution led to the concept of a singularity, a point where gravity is so intense that space-time collapses into an infinitely dense speck. Sound familiar? That's a black hole. Scientists predicted black holes decades before we had proof. And in 2019, the Event Horizon Telescope captured the first ever image of one, a glowing ring around a dark void, 55 million light-years away in the Messier 87 galaxy. It was a moment that shook the world, proof that Einstein's math could predict reality. But here's where things get wild. Black holes aren't the only solution to Einstein's equations. In 1935, Einstein teamed up with physicist Nathan Rosen to explore another possibility, a bridge connecting two points in space-time. They called it the Einstein-Rosen Bridge, but today we know it as a wormhole. Picture space-time as a flat piece of paper with two dots, point A and point B. The shortest path between them is a straight line, right? But what if you fold the paper so A and B touch? Suddenly, there's a shortcut. Wormholes do this in three-dimensional space, bending it through a higher dimension, a fourth dimension we can't see but can imagine. If you could step through a wormhole, you'd leap from one part of the universe to another, maybe even from one time to another. Let's make this clearer with a simple analogy. Imagine you're an ant crawling on a flat sheet from New York to Tokyo. It's a long trek. But if someone folds the sheet, so New York and Tokyo touch, you can hop across in a single step. That's what a wormhole does. It folds space-time, creating a tunnel between distant points. In 1957, physicist John Wheeler gave this idea its catchy name, inspired by a worm burrowing through an apple. Instead of crawling around the apple's surface, the worm chews straight through, taking a shortcut. Wheeler's term stuck, and wormholes became the stuff of scientific dreams. Now let's talk visuals, because wormholes aren't just math. They're a feast for the imagination. If you've seen Interstellar, you know the wormhole looks like a shimmering spherical portal, bending light and stars around it. That's not just artistic fluff. It's based on real physics. Scientists like Kip Thorne, a Nobel Prize-winning physicist who consulted on Interstellar, have modeled what wormholes might look like. Picture a glowing, translucent sphere, like a crystal ball, floating in space. As you approach, the stars behind it warp and twist, like looking through a funhouse mirror. Step inside, and the universe stretches and compresses, a kaleidoscope of light and gravity. There's even a website, check the description, where you can play with 3D simulations of wormholes, seeing how Earth shrinks as you plunge through. It's haunting, exhilarating, and a little terrifying. But here's the cold, hard truth. Wormholes are still theoretical. We've never seen one, never detected one, never even confirmed they exist. They're a solution to Einstein's equations, sure, but so are a lot of weird things. The universe doesn't owe us wormholes just because the math says they're possible. So why do scientists take them seriously? Because the same equations that predicted black holes, once thought to be pure theory, turned out to be right. If black holes are real, maybe wormholes are too. And if they are, they could be more than just shortcuts. They could be time machines. Yes, you heard that right. Wormholes might not just bridge space, they could bridge time. Here's how it works. Time and space are intertwined, according to Einstein. If a wormhole connects 2 points in space, it could also connect 2 points in time. Imagine stepping through a wormhole and emerging not just in Andromeda, but 10,000 years in the future or the past. This isn't just science fiction, it's a consequence of the math. In fact, some wormholes, called closed time-like curves, could theoretically let you loop back to your own past, raising all sorts of mind-bending paradoxes. Could you meet your younger self? Change history? Scientists like Stephen Hawking wrestled with these questions, arguing that nature might forbid time travel to avoid paradoxes. But the possibility is there, lurking in the equations, daring us to dream. Now let's get to the million-dollar question. Could humans actually travel through a wormhole? This is where the excitement meets reality, and it's a roller coaster of hope and doubt. First, we need to figure out how a wormhole would even form. The math suggests they'd require insane amounts of gravitational force, something only a black hole could provide. Einstein and Rosen theorized that a black hole's immense gravity could pinch space-time so tightly that it forms a tunnel. But here's the problem. If one end of the wormhole is a black hole, anything entering would be crushed into a singularity, not exactly a pleasant trip. So, what's on the other end? There needs to be an exit, something with equal but opposite power to a black hole. Enter the white hole. White holes are the cosmic yin to a black hole's yang. If a black hole sucks everything in, a white hole spits everything out. Nothing can enter a white hole, not light, not matter, not even a spaceship. It's a one-way exit, a theoretical opposite predicted by Einstein's equations. The term white hole was coined in 1964 by cosmologist Igor Novikov, who imagined them as the time-reversed version of black holes. Picture a black hole's event horizon, the point of no return. A white hole has an event horizon too, but it's a point of no entry. Objects inside can escape, but nothing outside can get in. Some scientists even speculate that the Big Bang itself was a massive white hole, spewing out the universe's matter and light. But here's the catch. White holes are even more theoretical than wormholes. We've never seen one, and there's a big reason why they might not exist. The second law of thermodynamics says that entropy, disorder in the universe, always increases. Black holes increase entropy by shredding stars and planets into chaos. A white hole, by spitting out ordered matter, would decrease entropy, which physics says is impossible. It's like unbreaking an egg or untearing a piece of paper. Nature doesn't work that way. In 2006, scientists got a glimmer of hope when NASA's Swift satellite detected a mysterious gamma-ray burst, GRB 060614, that didn't match any known phenomenon. Some speculated it could be a white hole, but no similar events have been seen since. For now, white holes remain a tantalizing what-if. Even if wormholes and white holes exist, traveling through them would be a nightmare. Wormholes are unstable. Gravity wants to collapse them the moment they form. To keep one open, you'd need something called exotic matter, a bizarre substance with negative mass that pushes against gravity instead of pulling. Exotic matter is theoretical, and we've never found it, though some quantum effects, like the Casimir effect, hint it might be possible. Then there's the radiation problem. Wormholes could amplify energy, bombarding travelers with lethal doses of radiation. And if you're thinking of steering a spaceship through one, good luck. Navigating a tunnel of warped space-time would make threading a needle in a hurricane look easy. But don't lose hope yet, because science is full of surprises. In 2015, researchers at the Autonomous University of Barcelona pulled off something incredible. They created a magnetic wormhole in a lab. Not a gravitational wormhole, but a magnetic one, using superconducting materials to channel a magnetic field from one point to another, invisible to the outside world. It was a proof of concept, a baby step toward understanding how wormholes might work. If we can manipulate magnetic fields this way, maybe one day we'll crack the code for gravitational wormholes. And that's not all. Scientists are exploring other ways to cheat the cosmic speed limit. Take the Alcubierre drive, a mind-bending idea proposed in 1994 by physicist Miguel Alcubierre. Imagine a spaceship that warps space-time around it, contracting space in front and expanding it behind, like surfing a wave of space-time. The ship itself wouldn't move faster than light, but the bubble of warped space would, carrying the ship along. It's like folding the universe to bring your destination closer. The catch? It requires exotic matter and energy levels equivalent to the mass of Jupiter. Still, it's a reminder that wormholes aren't our only hope. Einstein's equations are a treasure trove of possibilities, and we're only scratching the surface. Let's zoom out for a moment and feel the weight of this journey. Humanity has always been driven by the urge to explore, to cross oceans, climb mountains, touch the stars. The Milky Way is our home, but it's not our destiny. The universe is calling, and wormholes, as wild as they sound, represent our refusal to accept limits. They're a symbol of hope, a testament to our audacity to dream bigger than the cosmos itself. Every step we take, every equation solved, every experiment run, brings us closer to cracking the code. In 2023, researchers at Caltech used quantum computers to simulate a tiny wormhole, not a real one, but a model that matched the math. It's a start, a spark in the dark. Now, let's get emotional, Because this isn't just about science, it's about us. Think about your dreams, your hopes, the people you love. Now imagine a future where humanity breaks free, where your descendants walk on planets and galaxies we can't even name. Picture a child born on a world orbiting a distant star, looking up at a sky we can't imagine, knowing their ancestors dared to cross the void. That's what wormholes represent, not just a shortcut, but a legacy. Every scientist working on these ideas, every dreamer gazing at the stars, is fighting for that future. And you're part of it, because curiosity, wonder, and hope are what make us human. But the road is long, and the challenges are brutal. Wormholes might never exist. Exotic matter might be a pipe dream. The universe might laugh at our puny attempts to outsmart it. Yet isn't that what makes this quest so epic? We're not just fighting gravity or distance, we're fighting the unknown, armed with nothing but our brains and our guts. The same species that went from stone tools to moon landings is now daring to rewrite the rules of space-time. If that doesn't make your heart pound, nothing will. So where do we go from here? Keep learning, keep dreaming, keep pushing. Dive into the science. Check out books like Kip Thorne's The Science of Interstellar, or websites like NASA's Exoplanet Archive. Support missions like the Breakthrough Starshot, which aims to send tiny probes to Alpha Centauri, our closest star system, in just 20 years. And most importantly, never stop believing that we can do the impossible. The universe is vast, but our spirit is vaster. Wormholes might be the key, or they might be a dead end. But either way, we'll find a way to the stars. If this journey has sparked something in you, join me in exploring more. My AI Masterclass, link in the description, dives into tools that can help you visualize the cosmos, from generating starry skies to modeling wormholes. It's over 2 hours of live learning, covering image creation, video editing, and more, all to fuel your curiosity. And if you want to dig deeper into black holes or the Big Bang, check out my other videos. Links are below. Let's keep this fire burning, friends. The universe is waiting, and we're just getting started. Thank you, and I'll see you among the stars. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up